Okay, let's give you guys some practice now. So when given a velocity time graph, remember if you differentiate this, it will give you the acceleration, and when given a displacement time graph. By the way, we would sometimes use d for displacement, sometimes we would use s. In this case, we used s. So remember, when given a displacement time graph, if you differentiate it, it will give you your velocity. So given s here. You can think of this as a graph of s here, and when you differentiate it, it will be ds by dt. So when you've been given s, if you differentiate it, well, ds by dt is like velocity. So you can think of this ds by dt. You can think of it as being velocity. So this here, velocity equals this thing here. You can think of it like that. Okay. Well, anyway, given the velocity equals this here, which is this graph here. And given that the position, the displacement at time equals 2, yeah. So at time equals 2, the displacement is 1. So given this initial condition here, find the displacement at time equals 10. Okay. So this is a question here. So basically, you've been given velocity here. Find the indefinite integral, and then that will give you a formula for s, and then from s you can plug in 10. Okay, and the thing is, when you find the indefinite integral of this, you're going to get s equals something something, and then plus c. So here, so you would use the initial condition here in order to find c here. So this would be your s here, and then you would stick blah blah blah. So use this to find your c. Well, anyway, do whatever you want. Find this. Okay. So press pause and have a go. Okay. So to do this here, so given ds by dt, if we want s, we would find the indefinite integral of this whole thing here. So given this, find the indefinite integral. That would then take you to here. Okay, so the definite integral of this is this here. When you come to do this here, visualize this bit here as t to the power of minus 2. So you've got to think what would differentiate to give you this. Well, try t to the power of minus 1. So when you differentiate t to the power of minus 1, this goes down. So that will be minus 1, and then t to the power of minus 2. You see here you've got your minus 2 here. Well, anyway, when you find the indefinite integral of this, it will give you this. Okay. If you want to tidy it up, so this is exactly the same as this. By the way, I just switched these two over. Okay, so this is this thing here, and then you've got a negative here. So switch it. So anyway, this thing here will become this here. Okay, and then from our initial condition here, we now need to put down. So we've got our s here. S equals blah blah. We need to find out this c. So use the initial condition here. When time equals 2, so we've got to put this into here, and then put the 2 into here, and then this is well, we would put this into here. So this would be 1. Okay. Well, anyway, if you do that, it would take you to this, and then it's blah 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 to find c. So c equals negative a half, and then now you've got your so now you can remember we were here. We needed to find c. Now that we've got c, we can put it into this thing here, which will give us this. Okay. So now we've got a complete equation for the displacement. So if we want to know the displacement at time equals 10 here, then put it into here, and then blah blah blah. That will then give you this. Okay.